liberty, in it with you.
Did you know that a co-founder of Apple, Ronald Wayne, sold his 10% stake in the company for just $800? Ronald Gerald Wayne co-founded Apple Computers with Steve Jobs and Steve Wozniak on the 1st of April 1976. 2 weeks later, he relinquished his 10% stake for $800. He had recently lost money on another venture and was worried about risk. Had he kept his 10% till today, it would be worth billions of dollars.
Welcome to another beautiful Tuesday afternoon, and we're doing all about physical sciences. Welcome to the show. My name is Tobi Lenkosi, and today we'll be looking at the final couple of questions for the final NCS paper that was written last year in December for grade 12s. I want to send a big shout out and a big hug to Liberty. Thank you so much for sponsoring the show. Truly, none of this would be happening if it wasn't for you guys. Thank you so much for giving us the platform and to actually help our grade 12s prepare for the final NCS paper, especially under the conditions that we are under. Another thing, grade 12s, if you haven't done it yet, please do download the Tenfold education app. It is an app filled with tons and tons of past papers with the memos that can actually help you guys prepare for your final NCS. Remember what I always say, it's better to do a topic in the class than actually go to the Tenfold app and then see how much you can actually get right and then refer back to the memos to see if you got it correct. If you're wondering what question paper we are doing and you'd like to join into the fun, please do send a hi on the WhatsApp number on the screen and you'll meet our friend Dexter, and just like you, he just wants to learn. And therefore, we will then send you the question paper that we are doing today. If you want another platform where we can actually help you prepare for your final question paper, then please do follow us on YouTube, and we are Mindset Learn on YouTube. Once again, thank you so much for joining the show. And last week we did up to question number 7. So in this week we are going to continue with question number 8. So question number 8 is electrochemistry. Now, some of this electrochemistry actually you learn in grade 11. So if you're feeling like you kind of sort of forgot what is actually going on and so forth, then please do refer back to your grade 11 content. But nonetheless, let's see what the question says. So the question reads, the electrochemical cell illustrated below is set under standard conditions. Now, we know from grade 12 we've got standard conditions, and when the standard conditions occur, then something can happen to the reading on the cell and so forth, and the cell can actually occur in different sets of ways under standard conditions, right? So under standard conditions, that's what we are told. This is the cell that's given. I can already see that this is a galvanic cell. Remember, there's a difference between an electrolytic cell and a galvanic cell. Galvanic cell will have two beakers and it will be connected by a salt bridge. I can already see that that is named X. I can see that the V is a voltmeter. I can see that hydrogen gas will be escaping there. I've got platinum that is attached there, and I've got hydrogen ions in aqueous solution. And on this side, I've got magnesium, and then I've got magnesium 2+ ions, also in aqueous solution. So now what I always say when you are actually tackling a question like this, the important thing to do is actually look at your standard table. So now I know that we have a 4A and we have a 4B. I personally prefer using the 4B, but however your teacher has taught you, then it's the best one to look. Now, once you have a question like this, it's better to go see on that table which one is the highest. Is magnesium at the top? Is the hydrogen at the bottom? And then you can actually see where and which one actually goes under oxidation and which one then undergoes reduction. By actually knowing that, it actually simplifies so much easier. So what I would actually do if you're answering this question, I would actually say that magnesium is an anode or a cathode, and then by the H+ or the platinum, is it actually undergoing oxidation or reduction? But to simplify, let's do it all together one step at a time. So let's look at our first question for question number 8. So number 8.1 says, compound X completes the circuit in the cell. We must state only one. The examiner only wants one, and we don't want to get penalized by writing them a paragraph. State one other function for compound X. Let's go back to our diagram. I can see that compound X is my salt bridge. So they only want one that you could have said. Now, for salt bridge, I'm going to give you two, though. But the first one, it ensures electrical neutrality. It ensures electrical neutrality. In a cell, that's one of the stuff that a salt bridge does. Or, now remember, you don't have to write both. The examiner just wanted one. You could have also said that it provides a path for movement of ions. It provides a path for the movement of ions. Movement of ions. Now also remember that you guys must write in full sentences, right? And please don't write short sentence or try to shorten the words. Write in full proper English. Make sure that you've got capital letters so you're actually showing the examiner you know exactly what's happening. So that's 8.1. And then number 8.2 says we must define what is the term anode. Now remember guys, when an examiner, when the question paper asks for a definition, it's not what you understand. A definition is based on precise wording on a certain object aspect, and in this case, it's the anode. Not what you think is an anode, not what happens at an anode, the definition of an anode. And now the definition will always be the same, so you must make sure this is something that you need to learn off by heart. But if we had to define an anode, now usually there's more than one explanation. I'm going to give you the shortest. It is the electrode where oxidation takes place. You must say electrode. You can't say place, right? Because oxidation and reduction takes place at the electrodes. So the electrode where oxidation takes place. And you cannot fail explanations and definitions because you are lazy to read. I can see here this is for 2 marks, and we have to get the 2 marks, definitely. So now let's look at number 8.3. 8.3 says I must identify the anode in the cell above. I just want to take it a little bit back. Now we learned an ox and we learned about red cat. So at the anode we have oxidation and reduction takes place at the cathode. So if you use your 4A, your standard 4A and 4B table, you must then look which one will be higher, which one will be lower between the two, depending on what your teachers actually taught you. So now if we had to identify which one it was, it'll then be my magnesium. Looking at my standard 4B table, it's represented by magnesium. So magnesium will be the anode on the, so anode is where oxidation will be taking place. And remember, we also have oil rig. Let me just write that, oil rig. Oil rig, oxidation is the loss of electrons. So my magnesium will be losing electrons, where reduction is the gaining of electrons, all right? So identify the anode on the cell. It's always nice to write the symbol, or you can write the name, right? So Mg is magnesium. Remember, capital M, small g, and that is then magnesium. That is the anode for this particular cell. Let's look at number 8.4. Number 8.4 says write down the reduction. We must write down the reduction half reaction that takes place in the cell. Now with the reduction half reaction, it's actually very simple, right? You need to actually identify first where is oxidation taking place and where is reduction taking place, right? Oxidation is the loss of electrons, so we are losing electrons, whereas with the other one, we are actually gaining, with the reduction, we're actually gaining the electrons. So if you're going to write me the reduction half reaction, you must make sure that the electrons are actually in the correct side of this balanced equation. So where does reduction take place? I must write a full reaction for number 8.4.1. I've got 2H plus. Remember, you always need to actually add your charges. It's very crucial in chemistry that you add your charges. I've got 2E minus, and then I've got H2, and that is my reduction half reaction. You cannot fail this. This you find on your table, and this was also going for 2 marks. Let's look at 8.4.2. I must give the name or the formula of the reducing agent in the cell. Now, most of you guys get confused by reducing agent and the oxidizing agent, right? If you understand oxidation and reduction, then it's just vice versa when they ask you about the reducing agent and the oxidizing agent. And in this case, they say name or formula of the reducing agent in the cell. The reducing agent will be our magnesium. They do say the name or the formula. Remember, the name will be magnesium. And my formula will be Mg. Just want to take it up a little bit. The reducing agent is magnesium. I just want to show you here. By the anode, oxidation takes place at the anode. Oxidation is then our reducing agent. And that is then why magnesium will then again be our reducing agent for this. Now, the examiner is trying to catch you out here, but you can actually see it's only for 1 mark. So it's just something that you just had to know. Number 8.5 says I must calculate the initial, so the starting voltmeter reading of the cell under our standard conditions, and this is in for 4 marks. Again, there's about 4 formulas that you could have used or chosen from, and I've chosen this one. So I've got E cell, and I'm going to say E reduction. And I'm going to say minus E oxidation. E reduction minus E oxidation, right? The initial one. So initially 0 minus E oxidation, where the oxidation takes place on my table, it's negative 2.36, and that's the worst is over. I'm going to put it exactly as it is on my calculator. You don't really have to put the negative. You don't really have to work it out. But if you're really bad with negative numbers, a negative times a negative is a positive. So I'm going to get positive 2.36. I could have said negative 2.36, close my bracket, and then that's how I get it as a positive. But here we were just working with negative numbers. So I'm going to have 2.36. And the SI unit we use for the E cell is then a capital V. Remember, a small v means a velocity, and that is paper number 1. We have to use a capital V. Let's see what this question says. So now they're telling us that the magnesium half cell is now replaced with copper half cell. It is found that the direction, which makes sense, which the direction of the electron flow changes. Now, remember, us replacing magnesium and us replacing it with copper means the direction of the electrons will change, because it means that the oxidation and the reducing agents have now changed. Now, we must fully explain why there is a change in direction of the electron flow by referring to the relative strengths of the reducing agents involved. Now, I'm going to write it in full sentences. I'm first going to say that, remember, we had H2, which is stronger, or let me say is a stronger. H2 is a stronger reducing agent, Remember, it's for 3 marks, so we want to show the examiner exactly what you're doing. So H2 is a stronger reducing agent than my Cu, right? So now we've seen that this and this changing makes H2 a much stronger reducing agent than my copper, and therefore this means that my copper, you can write it as copper 2, or you could have just said Cu. My copper ions are reduced. They are reduced, which means my H2 is then oxidized. Now, if you are maybe having a bit of a problem with this question, I would have go back to my 4A or 4B table and then put my finger on the copper and the magnesium and then the hydrogen and then remove the 1 and then see how the electron flow will actually change, because H2 is now a stronger reducing agent than the copper, and therefore my copper ions are reduced and my H2 is then oxidized. And that is the last question that we have for question number 8. And then I think let's go for a quick ad break, and when we come back, we'll continue with question number 9.
Did you know that the average person will blink over 3 million times in a year? Blinking prevents the eyes from drying out by providing moisture to the eyes. It also serves to protect against irritants. It is estimated that we blink about 10 times per minute on average. If you add it up, the average person will blink over 3 million times in a year.
No one ever asks why we do the weird things we do. Like, why once is never enough? Or doing 2 trips is just one too many. Why do we, before we use these, or say 5 when we mean 20? Why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there, cross our fingers, touch wood, and struggle to hide our true feelings? At Liberty, we want to know all the weird and wonderful things that make us human, because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Welcome back to the show, guys. You are still sitting with me, Utobile Nkosi, and we are doing the final couple of questions for the final NCS paper that was written in the year 2020 in grade 12. I want to send tons of love again to Liberty. Thank you so much for sponsoring the show. Thank you so much for the platform that you're giving us so we can actually help our grade 12s actually prepare for their final school year, especially in the pandemic that we are in. And then again, grade 12s, if you haven't done it yet, please do download the Tenfold education app. It's an app filled with tons and tons of past papers that can actually help you guys prepare for the final NCS paper. And remember guys, if you actually are having a bit of a problem with those past papers on the Tenfold app, you can then screenshot it, send it through on Mindset, and we will then help you. Another thing, you can send a hi to the WhatsApp number on the screen, and then we shall send you the question paper that we are doing today. Also, if you want another platform where you want us to help you, please do follow us on our YouTube channel, and then there we are Mindset Learn. So right before the ad break, we did electrical chemistry, and we were looking at a voltaic or a galvanic cell. Now we're looking at question number 9. And question number 9 says, the simplified diagram below represents an electrolytic cell. Now there's a big difference between this one and the one that we just did. Represents an electrolytic cell used to electroplate. They used to electroplate copper ion, copper coin with silver, right? So I just want to elaborate a little bit quickly on what electroplating is. So what they do is they will take a piece of metal, and then they will let it lose some ions, and then they will cover a certain other metal. Most of our cutlery and our jewelry, your car rims, and all this stuff is actually goes through electroplating. So it actually is all part of electrochemistry, right? So I just want to show you the difference between the two cells before we start answering, so that you actually know how to identify them. So with this cell here, I can see that I have a battery and everything is in one beaker, right? So with the previous one that we did, I see that I've got a voltmeter here. That's why we were asked to calculate the voltmeter reading. We were also asked to give one function for X, which is our salt bridge. When we talk about a galvanic or a voltaic cell, we need a salt bridge which just like provides pathway for the ions and ensures electrical neutrality in the cell and so forth. We've also got two solutions. We've got two beakers in two different solutions. Whereas if you look at this question, everything is in one beaker, and both the objects in questions, which will be your anode and your electrode, will both be in one beaker and both will be in the same solution. Right? Now in this case, I see that this is a copper electrode that I'm given. This is a copper coin, and we need to coat this copper coin with silver, right? We call this electroplating. Call this electroplating of a copper coin with silver. Then again, you're going to need the 4B and the 4A standard table, where we're going to be identifying what is my anode, what is my cathode, where is oxidation and where is reduction taking place, what is the reducing agent and what is the oxidizing agent. Remember again, I prefer using the 4B table. If your teacher has taught you another way to use it, then you can use whichever one. What I would do first, by just looking at it, I would go to my table, highlight my silver and highlight my copper, and then I'll see which one is an anode and which one is a cathode. But then again, we're going to do it together step by step. So let's see what the questions are that follow. So the first one says, I must define the term electrolysis. Remember what I said in the previous question. The examiner will always ask you for definitions. And guys, you cannot fail because you're lazy to read, right? So I would say go through all your definitions every single night if you have to. But definitions are things that you have to learn off by heart. The examiner wants to see that you can actually state precisely what electrolysis is. A definition is not what you understand. You're also not explaining to the examiner what electrolysis is. You're trying to give the definition. So the definition for electrolysis, again, there are usually more than one definitions that we can give, but I'm going to give you one. So define the term electrolysis. It is the chemical process in which electrical energy, and we already saw that we have a battery or a cell there that needs to be present for it to actually work, but in which electrical energy is converted to chemical energy. To chemical energy, which actually makes sense. I actually want to go back to the diagram. I see that I've got a cell there. It would have been a battery if I had more than two cells. But in case, for argument's sake, this is then a cell. And I can see that I need this electrical energy to convert so that this process can take place, so that this silver ions can actually go all the way around and then coat the copper coin, right? We need the battery. Whereas in the previous one, we were only measuring the value of the cell, of the E cell potential, So that's the difference of the chemical process in which electrical energy is converted to chemical energy. Again, please use full words and full English. You want the examiner to see that you know exactly what's going on. Number 9.2 says, which component in the diagram indicates that this is an electrolytic cell? Now remember, there's a difference between a galvanic and a voltaic cell and an electrolytic cell. The difference between the two is this one is in one beaker, the other one is in two beakers. We have two solutions in the other one. Here we only have one. And then we have a cell there. We only had a voltmeter. We had two beakers and two different solutions. So one of the things that can actually show us which component which indicates that this is an electrolytic cell, it is the battery. It is the battery, because without the battery, even though they are in two different solutions, and this one is only in one solution, for this process to take place, we need the electrical energy from the cell to actually make the process go on. So we need the battery. And I can see that was only for 1 mark again. Number 9.3 says, we must write down the name or the formula of the electrolyte. Let's see, electrolyte is just a fancy way of saying solution and stuff, but we must write one word of the electrolyte that's present. I can see that, the electrolyte that will be present, it is silver. So that will then be silver nitrate. Electrolyte is a solution that we have in the beaker. So that will then be silver nitrate, because I do have silver here. What happens? Remember, the silver needs to coat the copper coin, so it means that the silver will lose silver ions in solution, and then they will then coat the coin. So that then means my electrolyte will be silver nitrate. Silver nitrate. Let's look at number 9.5. So this question says, I must write down the balance. This is very crucial, but balancing we learned in grade 10. We must write down the balanced equation of the half reaction that takes place at the silver electrode. Now, I just want to go back to the diagram that I'm given. Using your 4B or your 4A standard table, I know that the silver must coat the copper. So the silver will lose its electrons and fall into solution. So therefore, my balanced equation, remember I've got a silver, which is on a rod. It loses electrons to become Ag+, and then it will have a E-. Just to also elaborate on this, most of you guys confuse silver and gold. Think of it as silver and gold, right? So I see most of you guys actually confuse the two, but that's how I remember it. But this is then the balanced equation that you will have. We've got silver on the rod. It then falls into solution because it lost an electron. So this is the direction in which it will look. Make sure that the electron is in the correct side. And then that would have then been for 2 marks. And that is all for electrochemistry. This is how I would have then answered the questions for question number 9. The important thing is between question number 9 and question number 8 is to identify which one is a galvanic or voltaic cell and which one is an electrolytic cell. Also be very flexible on how to use your 4A and your 4B standard table. Nonetheless, I will see you again after the ad break.
Did you know that a full head of human hair is strong enough to support 12 tons? We have on average about 150,000 hairs on our head. According to research, the molecular structure of hair is such that a single strand can support about 100 grams. This means that the combined hair on the average human head would support over 12 tons, which is about the weight of 2 African elephants.
Welcome back to the show, Grade 12s. Thank you so much for tuning in. You are still sitting with me, Tobile King. Welcome to the show. We are doing the final couple of questions for the 2020 final NCS question paper that was written last year. I want to send tons and tons of love again to Liberty. Thank you so much for sponsoring the show, and truly none of this would be happening without you guys. Thank you so much for the platform that we have been given to actually help our grade 12s to actually prepare for their final NCS question papers. And grade 12s, if you haven't done it yet, please do download the Tenfold education app. It is an app filled with tons and tons of past papers for maths, physics, life sciences as well, where you can actually find tons and tons of help, because it also has the memos that can actually help you prepare for your final question papers. Also, if you're wondering what question paper we are doing and you'd like to join in the fun, please do send a hi on the WhatsApp number on the screen, and we shall then be sending you the question paper that we're doing. If you're looking for another platform where we can help you, please do follow us on our YouTube channel, and there we are then Mindset Learn. Thank you so much once again for tuning in, and let's get into it. So before the ad break, we looked at an electrolytic cell, and before that we looked at a galvanic or voltaic cell, and I showed you guys the difference between the two. Now for question number 10, we're looking at the fertilizer industry. Now the fertilizer industry is a lot of reading, is a lot of graphs, it's also a lot of repetitive work that you need to remind yourself. One way that I think would be best would actually to be always draw the structure out for you when you're studying, and then you're able to see what happens, where what happens. Because most of the time, as you can see on my screen here, this is how they'd ask the question. They'll give you so many unknowns. For example, here, I've got raw material, S and T and so forth. So first things first, you need to know the different types of fertilizers that we get and the different types of processes that make those fertilizers. That's very crucial. And once you have done that, I would say draw yourself a diagram for each and every one. You must know the catalysts that are used, what is required, the number of processes, and then you are able to then answer this question. So it is quite a lot of work. Most of the time, it does not count a lot of marks, but this is one of the topics that you cannot fail. For example, if we need oxygen for the reaction, it'll always be oxygen. So you cannot fail something like that. You cannot fail because you didn't read or you failed to remember. So let's see what we're given here. So this is question number 10. And we are told that the flow diagram below shows how fertilizer B, now we're not told what is fertilizer B, is produced in industry. I can see that we add raw material S, we also add raw material T, we don't know what they are. And then I can see we then have nitrogen, and then we've got oxygen. Together, they make process number 1. Now, already that they've written this as process number 1 has a name. They'll ask you, what is the name of process number 1? So you need to know what process number 1 is when nitrogen and hydrogen come together. Now, after process number 1, the nitrogen and the hydrogen will form compound A. Now, we're not told the name or the formula for compound A, so then you need to go back to grade 10 and you need to start thinking, what can form nitrogen and hydrogen? You also need to know the charges that nitrogen and hydrogen will also have on the periodic table. Together they make compound A. We still don't know what is compound A. And then they've given us 2 streams. We can have process 2. Process 2 should also then have a name. But compound A, through process number 2, forms nitric acid. Aha, that's the first best clue they've actually given us. And then through that, I can move through this arrow here and get fertilizer number B. Or from process number 1, I can move to compound A, and compound A can move straight to fertilizer number B. So that's the entire process that I'm given, right? So now let's see what questions follow. So the first one, number 10.1.1, says I must name S, the name of S. Let's go back to our raw material here. So I can see that I have nitrogen and then I've got hydrogen, but S moves in that direction. So they are looking for this one right there. So S will be liquid air. So S will be liquid air according to this diagram. Remember, we still have to figure out what is the fertilizer that they're talking about. This is liquid air. And then it continues to say number T. What will then T be? I can see that T forms hydrogen. So raw material number T must be natural gas or methane. Remember, methane is CH4, and there are H's there that are then taken away. So for raw material number T will then be natural gas. You could have written any one. I don't think the examiner would have been very upset with us. natural gas, let me just write or here, or you could have said methane. And now we're very familiar with methane from organic chemistry. Let's look at the next one. We've got 10.1.3. Again, it says name or formula. Now remember, if they say name or formula, guys, you don't have to go draw both or write both. You just need to write one. So now they say we must give the name or the formula of the catalyst used in process number 1. Now we know that a catalyst will speed up the reaction rate by lowering the activation energy without actually taking part in the reaction. So let's see. We've got nitrogen, we've got hydrogen. They're looking for the catalyst that was used in process number 1 to actually get compound number A. And I can already see forming of nitric acid means that one of my catalysts that I could use is then iron or iron oxide. It's also very crucial that you know the definition for a catalyst, but luckily that comes from grade 11, so most of the time then you would have learnt it from them. Iron, or you could have said iron oxide. We can say iron or iron oxide. Okay, let me read it from here, then we'll go back to the structure if needs be. Now 10.1.4, it says we must write down again the name or formula of compound A. Now I know, looking at my diagram, that compound A is what will form when the nitrogen and the hydrogen undergo process number 1, and then we have compound number A. So compound A, and I see, process number 2 forms nitric acid. So compound number A will then give me NH3. That is the compound that will form from process number A. This will be NH3. And like I've been saying, guys, there's a number of fertilizers that you need to know. And for each and every fertilizer, you need to know the catalyst and you need to know what is produced. The only way you can do this is if you draw the diagrams. That's the one way that you can practice so that you know exactly what's going on and what's exactly to come. So let's continue. That was again for 1 mark. As you can see, this topic doesn't really count for much marks, but it's very easy questions. So the next one says, write down the name of process number 2. Like I said, the processes will definitely have a name and the examiner will definitely ask you. Because this is a fertilizer industry is it's actually a big industry. So process number 2, this is the process number here. So remember, we already found A, which was NH3. We've got process number 2, which is unknown. And then we find nitric acid. Now I can see the formation of nitric acid is actually through the Ostwald process. So nitric acid will form through the Ostwald process. Very, very critical, very, very crucial. They could have asked you sulfuric acid. You would have known the same. You would have had to know the same thing. The types of processes, the types of catalysts, and so forth. This one is actually a little bit easy because they only ask you for one. Sometimes they can ask you for all the types of catalysts, so be aware. So for process number 2, what is it called? That is then the Ostwald process. How do I know that? The Ostwald process forms nitric acid. Ostwald process. Let's look at 10.1.6. It says I must write a balanced equation for the formation, for the formation of fertilizer number B. A balanced equation for the formation of fertilizer number B. Let's go back here. So I can see that B occurs here. Let's see, we already found compound number A. Just want to use a different color. So compound number A was NH3. That's what we got. Process number 2, we found that it was the Ostwald process. This also works for me if you actually work on the paper. Ostwald process. Now I see, I need to form compound number B. So how will I then form compound number B? Using a balanced chemical equation. So this is how I'm going to do that one. The balanced chemical equation. Remember, for compound A, I was given NH3. I'm going to say plus. I've got HNO3. And then you have to you can either, so one of two ways. It's either you know how it will react and how it will form, or you have to know it prior to this. But remember, practice makes perfect. So nonetheless, looking at these two, I can see that NH3, HNO3 will then together give me the following. And how did I get this? This H will form with this H to change the NH3 to NH4, and I'll be left with NO3. So this will break into H plus, and this will be NO3. So this H right here will bond with that one, changing my number of H's from 3 to 4. So this will become NH4. And what do I still have? What do I have there? This is then NO3. So that is then the formation of compound number B. So question number 10.2. Now we are told that we've got a 20 kilogram bag of fertilizer, which is labeled as follows. Now, what does the ratio on the label represent? So I just want to, just quickly, most of the time, they give you a fertilizer bag like that. So this is how, it's not really how a fertilizer bag looks, but I just want to show you, because most of the time we are so familiar with what we are so used to seeing that if they wrote it any different, it might look completely different to us. So this is my fertilizer bag, and the question is asking me, what does the ratio represent? Remember, we've got 2 to the ratio of 4 to the ratio of 3, which represents my NPK ratio, right? So those ratio is my NPK ratio, my nitrogen, phosphorus, and potassium. Or you could have also said that is your ratio of primary nutrients, the ratio of primary nutrients. I just want to elaborate a little bit further on this, on the NPK ratio and why it's so important. So most of the time, if you are a farmer and then you see that your plants don't really look so green or your fruit doesn't really taste so nice, then we use fertilizer, right? But these ratio actually mean something. So when you're buying fertilizer, you must actually see what is the highest ratio in the fertilizer and what does that ratio actually help. Because sometimes the fertilizer is so great at making your plants green and they look so lively and juicy. Or sometimes it just really helps to improve the taste and, you know, the quality of the fruit and so forth. So this NPK ratio is very important because as a farmer, you need to know where you're actually struggling or where your fruits are actually struggling, and then you buy the correct fertilizer to improve those plants. So you need to know what the ratio actually means, how it actually structures, and how you calculate. Also, if you look at my screen, they've given us an X here. So this X tells us how much of this bag is then actually fertilizer. They've given us the ratio, yes, but how much of it is actually then fertilizer? Because sometimes you buy a whole 20 kilogram bag of fertilizer, but only to find that you only have 5 grams in that 20 kilograms, which is actually then fertilizer, right? So you also need to see in that 5 grams, is there a lot of nitrogen, phosphorus, or potassium? And then you're able to see what you then need. But these ratios are very important. They represent the NPK ratio. N is for nitrogen, P is for phosphorus, and K is then for potassium. So that is the NPK ratio, or the ratio of primary nutrients. Now remember, all plants need some sort of form of nutrients. Now, question 10.2.2 says the bag contains 2.315 kilograms of phosphorus. So what I would do here, I will write it here as NPK, so of phosphorus. So I can see that, phosphorus is over here. So this contains 2.315 kilograms. So can you already see? Out of the 20 kilogram bag of fertilizer, only 2.315 kilograms of it is actually phosphorus, right? So you can see that not the entire bag is actually fertilized, just a portion of it, and the rest of it is just then filler. So now let's see what the question is going to say. So they've already given us 1 to work from. Now the question continues to say, I must calculate the value of X. What am I calculating? I need to calculate what is this value of X. So how many kilograms is then there? So I found 2 ways in which you could have done it. I just want to expand my page. I'm going to need quite some space. So the first one that we could have done, I'm going to do it the long way around so that everybody is with me. I'm going to write it as we were given the ratio N, P, and K. And I was given the ratios of 2 is to 4 is to 3. And then I'm given an X over here. Now we know from grade 9, when you're working with ratios and you need to find the unknown of this ratio and so forth, the best thing to first do is to actually add those ratios, and then you're able to find the value of the ratio in those ratios. Doesn't make quite sense, but let me show you. So what I'm going to do is I'm going to say 2 plus 4 plus 3. So I'll find the sum of all of this. So 2 plus 4, that will give me 6, plus 3 will give me 9. Now I'm looking for X, but most of the information that I was given was for phosphorus, because I was given the mass of it as 2,315 kilograms. That's how much I was given. So what am I going to do? I'm going to work with the phosphorus because that's the amount of information that I have. Therefore, I'm going to say, let me work here. I will then say 4 over 9. Phosphorus is a ratio of 4, and this total is 9. I'm going to multiply it by, I'm going to say X, right, because that's unknown. And then I'm going to put it over 100, working at it as percentage. I want to go back to my fancy diagram over here. So I'm going to multiply it by the total value of the bag. Remember, I'm looking for the value of X in a 20 kilogram bag. So therefore, I'm just going to multiply this by 20 kilograms. And then for phosphorus, in the 20 kilogram bag, only 2.315 of it, 2,315 of it is then the P. So now I only have one unknown, and then now it's just mathematics. So let's see. I've got fractions, whole numbers. I'm just going to put this one over 1 so I can simplify this. Numerator times numerator times numerator. I'm going to try to do this one in my head. 4 times 20, 4 times 2 will give me 8, and I've got a 0, so that will give me 80x. Over 9 times 100, that should give me 900. That one was fairly easy. And I'm all equal to 2,315 kilograms. But now remember, I'm not done yet. I must still solve for x. If I'm working with a fraction on this side and a whole number on this side, I'm going to put this one over 1. And according to mathematics, I can therefore cross multiply. I'm going to multiply this with that, multiply this with this. I actually want to work it out, so I just put it in the calculator once. So I'm going to have 900 multiplied by 2,315, and I'm going to have 80x multiplied by 1. I'm going to have 80x, yet I'm not done. I'm still looking for the x by itself. Therefore, I can divide both sides with what is bothering the x, and in this case, it's the 80. So I'm going to divide both sides by 80. 80 and 80 in this side will cancel, because 80 divided by 80 is 1, and 1 times x is x. So let's put this one in my calculator, and then let's see what happens. Remember, I always remind my kids to always put brackets over around everything that you're using, so that you're guaranteed that your calculator will give you the same answer. Now, if you didn't do it like this and you kept rounding it off, most of the time the question paper will actually have a bracket of where you could have went wrong or what you could have gotten right. So here I get 26.04. Remember, we must always round off to 2 decimal places in chemistry and in physics. You look at the third number. If the third number is less than 5, so 4, 3, 2, 1, and then the number in front of it does not change. If the third number is 5 or greater, so 5, 6, 7, 8, 9, it'll change the number in front of it to its next value. So let me go out here. So I get 26.04. This will be 26.04, and this then will be kilograms. So that's the first way that we could have worked out this problem. I just want us to find another way that we could have worked it out. So remember, then again, I've got the ratio NPK. Now, you could have chosen anyone. I've got a ratio of 2:4:3. And I know that most of my information was given for the P, and I was told in the 20 kilogram bag, I've got 2,315 kilograms of phosphorus. Now, I'm looking for the mass of phosphorus, and I'm given 2,315 kilograms, right? That is the mass. Again, I'm going to add all the ratios. You're going to see how all of this is going to come to play. I'm going to say 2 plus 4 plus 3, and then I get 9. This part is mostly crucial in all the ones. So therefore, I'm just going to work here. I can say phosphorus is then equal to, remember, this is what I was given. I was given 2,315 all over 4. And this 4 is the ratio that I got there. and I can therefore find an answer. So now I want you to look carefully here. Can you see? Let me just get the answer first, and then it'll make it a little bit more easier for us. I've got 2.315, and that is all over 4. I'm going to write the whole decimal. So now I'm finding it as a decimal within this value that I'm given. So I'm going to write it down exactly as it is. Therefore, I get 0.57875. It's very crucial that you write your entire answer out and you only round off your final answer. Remember, guys, if you keep rounding off your answer to the next to 2 decimal places the entire time, it kind of moves you away from the bracket. What I always tell my kids is that if you're working with a long decimal, rather put it in exactly like that. Rather say memory plus on your calculator, and then you're able to plug it in exactly as it is in your next answer, so that you actually only round off your final answer to the 2 decimal places. Even though the examiners give you some form of a bracket, it's much more safer to do it like this. Or if you really don't want to write the whole thing, rather round it off to 4 or to 5 decimal places at maximum. But nonetheless, I found for phosphorus, this is the mass I'm given for phosphorus over a ratio of 4, and then I found this value. I'm going to do the same for N. Even though N is unknown, I'm going to use mole ratios. So I found the value of 1. So 2.315 divided by 4 gives me this, because there's 4 of these values in there. So I'm going to use stoichiometry again from chemistry. So I can say 1 of this times 2 for nitrogen, since there's a ratio of 2 in the bag. I can use this value multiplied by 3 for potassium, because there's 3 of them in a bag. Just want to elaborate a little bit further. Remember when we do stoichiometry, especially chemical equilibrium and so forth, then you have to use mole ratios. If this is 2 and this is 1, you must find the value of 1 mole, and then you're able to find the value of any of the other moles in the equation. So this is technically what I'm doing. So what I decided was, since I'm given the mass of phosphorus as 2.315 and the ratio is 4, I'm going to find the value of 1, right? Since all of them are ratios anyways. So for nitrogen, I'm going to use a 0.57875, and the ratio in the bag is a 2. So I'm going to multiply that by 2. So I'm going to have this value here exactly as it is. I'm just going to multiply it by 2. And then I get that whole answer again. I'm going to write the entire thing. I'm not going to round it off. I got 1.1575. And I'm going to do the same thing with the K. Remember, phosphorus gave me most of the information. They've already given me the amount of that there is of fertilizer in the 20 kilogram bag, which was 2.315. It is a ratio of 4, so I'm finding the value of 1 ratio so that I can find all of them in the bag. My K, my potassium, is a 3. I'm going to take this value over here, multiplied by 3, so that I can find the ratio. 0.57875. I'm going to multiply that by 3. Let's see what we get there. I'm just also going to put it in brackets, 0.57875. Let me just see if I wrote that right, 0.57875. And I'm going to multiply that by 3. Let me just go backspace there. There we are. And that is the number that I get. Again, I'm going to write the entire number, not rounding it off. 1.7362 and then 5. Now that this is now what I have for each and every ratio, I've used this one to find all the other ratios for them. The mass of this one was already given, so now I can find my total mass. I'm just going to go down a little bit so I can say my total mass. This one is a bit of a long method, but it's also pretty safer. And remember, my ratio is given, let me write it here, NPK. So now I've found the value of each and every ratio in the bag. So my N was 1.1575 plus my P was 0.57875 plus my K was 1.73625. Let's see what we get there. We are almost there. Not the final answer, but almost there. The first one is 1.1575 plus 0.57875 plus The last one is 1.73625. And then I get that answer. Let me see if I'm adding it wrong. I just want to add this one quickly here. With this one, we're going to add these ones. But for this one, we were already given the mass. We're already given the 2.35. There we are, 2.315. Yes, as you can see, it cannot be less than all of these ones because it has the highest ratio. So I used this one to find all the other masses. I found this one. I found this one. For P, it was already given. I just used it to actually use stoichiometry to find the rest. So I'm already given with this one. So let me just add that properly. So then let's try this again. 1,1575 plus 2.315 plus 1.73625. There we are. Then I get that entire answer. Again, I'm going to write the whole thing so that I only round off my final answer. Therefore, I find this as 5,20875 kilograms, but they're still looking for X. Remember, this is just telling me how much fertilizer now we have in a bag. We are then one step there. So now to find this one, I'm still looking for X, right? I just want to go back to my nice diagram over here in my previous slide. I just want to go back to this diagram. Remember, now that we found the value of each and every one, right? I'm still looking for X, but all of these values of fertilizer are in a 20 kilogram bag. So I must still find out, already I found the grams of them one by one, but how much of this is in a 20 kilogram bag? So that's the only way I'm actually going to find my X. Therefore, I can say my X, I'm going to say my 5,20875 all over the mass that I'm working at is 20. I'm going to multiply that one by 100 so that I can therefore find the mass present. I'm going to put it in my calculator exactly as it is. 5.20875 all over 20, and I will multiply that by 100. Aha, and there we get the same answer. I get 26,04. Remember, the third number will not change the 4 because it's less than 5. Therefore, I get 26,04, and this is in kilograms. Just want to go through this step quickly. So for this one, the crucial thing was I used the ratios that I was given. I had most of the information for my P. So now, the one thing that we had to do was use stoichiometry. Now, I know we're very good with stoichiometry already. So I'm going to use this stoichiometry of P to actually help me find the value of each of them. So I found the value of 1, which was 0.57875, and therefore I was able to multiply it by 2 so that I can find the value of the nitrogen in each one. And therefore I was then able to find the mass in each one, so that's in kilograms. I was already given the mass of P, and this is the 2.315 that I already had. So me finding the individual mass of each of the ratios that were given in the fertilizer, I was able to add everything together, which means in the 20 kilogram bag, 5,21 technically kilograms will then be my NPK ratio. However, I want to find the value of X. So this means if this is my fertilizer in a 20 kilogram bag, I can then multiply that by 100 to find my value of X, which is 26,04. Whereas in this one is a little bit shorter but a little bit confusing. Here's the bag that you're given. You also need to find X, and this was just mathematics. So I added up all my ratios. I took phosphorus because I took my P because that's the one we have the most information. So it was 4 out of a ratio of 9 multiplied. I'm looking for X. You take it as 100 multiplied by 20 kilogram bag. I do know that only 2.315 of it is actually fertilizer. And then what do I do? If you have only one unknown in mathematics, then you are able to solve it. Cross-multiplied, and then I again found 26,04. As you can see, in both equations, I didn't round off my answer to the nearest decimal places in every single time. I managed to actually try and plug in everything all at once in my calculator. That's why I got my answer exactly the same in both sides. This one is a little bit tricky, but you'll see as you keep practicing, you get better at it. And if you are still struggling, rather do it the long way around on the one that I showed you on method number 2. It's a little bit long, but it's also very accurate and it actually makes sense. But nonetheless, thank you so much for joining me in today's show. I will definitely see you next time. All the best for your June exams that you guys will be writing and all your preparations, and I'll see you next week.